In this chapter, we're going to review some topics in algebra that will help prepare us for the calculus course that's coming up. In this lesson, we're going to review different methods of factoring.
So now we're going to take some time and look at arguably one of the most important tools that you should have accumulated while you're in high school here. That's the ability to factor. We're just going to try to review some of the patterns that you've seen and introduce a new one to you that you might not have seen before here. So we're just throw some examples down. So I just want to factor the following. So let's say we start with 2x squared plus 7x plus 3. Okay, that's just your standard trinomial. Okay, I think most of us know how this works. This is going to break apart into two binomial factors. Now, you may have learned some methods of factoring in back even as far as grade 10 or maybe even earlier depending on where you're going to school. There are all sorts of different methods for doing this, but I think it's pretty safe to say that I don't think there'd be many people that would argue this, that based on the level of factoring we're going to do here, guessing and checking is probably the fastest method of any of them. And I know that doesn't sound very sophisticated, but believe me, it works here. Because I know, for example, that 2 is prime. So I know that 2 is going to break down into 2x and x. Because remember, when I expand this out, the product of these first two terms is going to give me that result right there. Now, 3 is also prime. So it can only be broken down into 3 and 1. Now, that's either going to be 3 and 1 or 1 and 3. That's the part that I don't know. And in fact, that's the only part that I don't know. Now, I do want the sum here to be 7 when I expand out those two factors here. Because remember, that middle term there is always the sum of the two linear factors that I get. So, like, I'd be very tempted to make this plus 1 plus 3 so that I can multiply that out and get 2x times 3 is going to be 6x plus 1 times x, 1x. There's where my 7 is coming from. And there it is. I factored that. Okay? Just by essentially guessing and checking. Let's do another one here. Let's say that I've got negative 6x squared plus 7x minus 2. Again, just another trinomial here. Now, when I look at this, there's something that I see here that I don't quite like. And when I teach this, my students all know about this. I like to make things look pretty. Right now, this doesn't look pretty. And it doesn't because there's a negative in front as a leading coefficient. I don't really like that in terms of my polynomial. So what I'm going to do to start off with, and I know this isn't much, this isn't a really big step here, but man, does it ever make things nicer for me. I'm going to take and put that negative outside there and make this 6x squared minus 7x plus 2. Now, I'm going to factor that trinomial. Now, 6 can be broken down in a couple of different ways. It could be 2 and 3, or it could be 1 and 6 here. My first guess, I'm going to just go with my gut on this one, 2 and 3. Okay? And now 2 is a prime number, so it's either going to be 1 and 2 or 2 and 1. Okay? But I do want that middle term to add up to a 7 here. Now, it doesn't make sense for me to guess even 2 and 1, and I hope everybody sees that. If I put it, I'll just do this lightly here. If I put a 2 here and a 1 here, notice that what I've done is I've created a binomial that has a common factor of 2 here. Okay? Now, my original did not have a common factor of 2, so I've inadvertently created a scenario where there was one. That doesn't work. That doesn't work. I shouldn't be introducing this new factor here. So 2, even as a guess, 2, 1 doesn't make sense. But 1, 2 would. Okay. Now, notice that the last term here is positive, meaning that these two values here are either both positive or both negative. And that middle linear term there, its coefficient is negative. So these must both be negative here. Now let's just double check that. 2x times 3x is 6x squared. Good. 2x times negative 2 is negative 4x. Negative 1 times 3 is negative 3x, and together there's my negative 7. There it is. So there's that polynomial in factored form. Okay, good. Let's try another. Let's take a look at x to the 4th minus 13x squared plus 36. Okay, now, when I take a look at this, it's important to note that this is not a quadratic. However, it does have the overall structure of a quadratic. And so this is where I start to get really kind of into what's going on here in terms of the mathematics. I love this stuff. Because what we've got here is as a problem. I want you to factor it, but there are actually two different levels to this. Okay? The outer structure of this thing is quadratic, even though this function is technically a quartic. And the reason why I say it's quadratic here is because if you look back at a quadratic, an obvious quadratic, I've got a quadratic term, the linear term, and then the constant term. But notice the pattern here, 2, 1, 0 in terms of the degree. This follows a very similar pattern. If you multiplied those all by 2, I would go 4, 2, 0. So this is related to that. And so what I'm going to do here is I'm going to introduce a variable. I'm going to let a be equal to x squared. Because I would love it if this middle term here was linear. So I'm going to force it. I'm going to call that by a and make that look like a linear factor. So now this is going to become, okay, a squared, because if I've got x to the fourth here and a is x squared, then a squared would be x to the fourth. That's how those are linked. Minus 13a plus 36. Now I'm going to factor this one. This expression right here is showing me what the overall structure is. Now there is a deeper structure in there because of the x squared, but I'll get to that in a bit. First of all, I'll break this up into the two binomials. A squared breaks down into a multiplied by a. That's not the hard part. And then 36. What are my factors of 36? Now I have to be able to combine them to get negative 13. And actually, it doesn't take me much thought here to see that this is going to be negative 9 and negative 4. Okay, there we go. So there's how the immediate structure of this thing factors down. Now this is not the final answer though, because my original question didn't have a in it. My original question was in terms of x. So therefore we can write, that x to the fourth minus 13x squared plus 36, okay, has this form of factoring, but not with an a, with an x squared. So it becomes x squared minus 9, x squared minus 4. Okay, so I had a little detour, okay, went off to the side, did a little bit of factoring to simplify that overall structure, and now I've got it down to this. Now I'm not quite done yet because I've generated two binomial factors, and I noticed that each one of these things is a difference of squares. So x squared minus 9 is going to become x minus 3, x plus 3. X squared minus 4 is going to become x minus 2, x plus 2. Okay? Now if I was really concerned, I would organize those in terms of the order of their roots here, but I'm not all that concerned about that. As long as they show up here, that's all I need. Order does not matter with multiplication, so that's good. Like that question. Okay? Let's take a look at another one. Okay, this time let's try something a little different. Let's make this a 4-term polynomial. So 4x cubed minus 32x squared minus x plus 8. Now, I'm going to show you two different ways of factoring when you got 4 terms here. I'm going to do a couple questions here. When you see 4 terms like this, the very first thing that you should be looking for is grouping, what we call factoring by grouping. Okay? Now, what I mean by that is I'm going to group together the first 2 terms. I'm going to group together the last 2 terms. Now, the big mistake that people make is they simply drop parentheses around these things and then make it look like, inadvertently, like you're multiplying stuff together. We want to pull the first 2 terms apart. I'll put parentheses around them. And then we're going to add those last 2 terms. Now I'll put parentheses around those. Now it's really important that I put an addition sign in between. I put parentheses there, and that negative that showed up in front of that linear term continues to be in front of the linear term, but just the linear term. Big mistake that sometimes gets made here as well is people will do this. They'll go 4x cubed minus 32x squared, and then they do minus x plus 8, and they drop parentheses around that right away, putting the negative in between. But if you were to try to go backwards now, try to go back up to the original by distributing that negative through, you would get a negative 8 here. But it's supposed to be positive 8. But what you've written here would produce a negative 8. So these are not the same. Okay, you can't just do that. You really do need to group those last two terms together and put an addition sign in between. Now, this is going to be equal to what? Well, what am I going to do here? Well, what I'm going to do with each one of these things is simply apply one of the earliest forms of factoring that you looked at, and that was factoring by common factoring. What factors are common to both of those terms here? Well, a 4, and then I'm always looking for, like when I look at the variable, I'm always looking for the smallest exponent, because that would definitely be common. I can't pull out an x cubed out of both of them, but I could pull out an x squared, and when I do that, I will be left with x minus 8. So that's what I'm left with. Now, I really want this to end up looking like this when I'm done. This factor, or this binomial here, doesn't look right though. The signs are wrong. So I can actually pull out a negative out of that and make that x minus 8. Fantastic. And now I've got this binomial factor that's common to both, so I can factor that out. So the x minus 8 comes out. From the first term, I'm left with 4x squared. And from the second term, I'm going to be left with this coefficient of negative 1 there. So now I've done the factoring by grouping. Okay, I got it down to x minus 8 multiplied by 4x squared minus 1. But I'm not quite done yet here, because notice what I'm left with here is also a difference of squares. Okay, so I can write that as 2x minus 1 and then 2x plus 1. There's a lot going on in that question. All right, now let's take a look at another one that's going to be a little bit of a bear compared to the one that we just did. Okay, so here we go. X cubed minus 10x squared plus 19x plus 30. Okay. Well, this one is not going to factor by grouping. And actually, I can see that right away, because if I group together these first two terms, group together these last two terms, now notice the only thing common to these two terms is the x squared. And that would leave me with x squared times x minus 10. 19 is prime. That's causing me a problem. Okay? That 19 is causing me a problem because I'm not going to be able to factor anything out of that unless I can factor out the 19. And I can't factor out the 19 out of the 30. So that is actually going to cause me a fair bit of difficulty here. So the way this is situated right now, that's not going to work out for me. So another thing that I could do here is rearrange the terms here and group them differently. Because sometimes grouping will work if you just move things around here. But in this particular case here, no matter what I do, I'm going to end up having to combine that positive 19x with something. And the truth is, I'm not going to be able to factor it out regardless. So I'm going to run into a bit of a problem with that. So what I will do here is something different. And so what I need to do is, got to play with this a little bit here. I'm going to use the remainder theorem and the factor theorem, and I don't know. You're supposed to remember that. You're supposed to have looked at that before here. That's hard to say whether people have or they haven't here. The way we approach this is we look at the constant here, and we look at possible factors of the constant. Okay, and so the possible factors, what we call the integral zero theorem, says that with 30 here, a possible binomial factor could be x plus 1, could be x minus 1, or x plus or minus 2, or x plus or minus 3, or x plus or minus 5, x plus or minus 6, okay, and then x plus or minus 10, x plus or minus 15, x plus or minus 30. So notice that the values that I'm using here are all factors of 30. Now the rule that I've just hinted at here is actually, in reality, a little bit more complicated than what I'm doing here with it. But for our purposes here, I only really need to concern myself with the constant at the back there. So these are all possible factors. Now I don't know which one. So what I'm going to do to start off with here is I will test my x minus 1. Okay? So I'm going to test to see if x minus 1 is in fact a factor. And I do that by evaluating my polynomial at positive 1. So when I do that, I will get 1 cubed minus 10 times 1 squared plus 19 times 1 plus 30. Oop, that's off the screen here. Now, what happens when I do that? Well, I'm going to get 1 minus 10 plus 19. So 1 plus 19 is 20, plus 30 is 50, minus 10 is 40. Okay. Now think back and let's talk about what the significance of that is. That is therefore the remainder when that polynomial is divided by x minus 1. Okay, now because I'm getting 40 and not 0 as a remainder, I know that that's not a factor. So x minus 1 doesn't work. Let's try x plus 1. Which means I would substitute in negative 1. So now to test that, negative 1 cubed minus 10 times negative 1 squared plus 19 times negative 1 plus 30. So what are we going to get here? We're going to get negative 1, there's that negative 19, so it's going to be negative 20. Negative 1 squared is going to be 1 times negative 10 is negative 10. So negative 10 and negative 20 is negative 30. Plus 30, there's my 0. So, okay, so I know that the remainder here is 0 when I divide by x plus 1. So that means x plus 1 is a factor. So now what I'll do is I'll go one step further. I'm going to do synthetic division here. And I know we've talked about this before, synthetic division. I'm going to divide this thing out here. I'm going to put a negative 1 there. My coefficients will be 1, negative 10, 19, and 30. So bring down the 1, multiply, add, multiply, add, multiply, add. So there we go. So therefore, my polynomial, okay, could now be written as x plus 1 multiplied by x squared minus 11x plus 30. And I'm so close, but I'm not quite done yet, because this trinomial can be factored. Sorry about that. I just need factors of 30 whose sum is negative 11. Factors of positive 30 whose sum is negative 11. Now, immediately my head wants to go to 15 and 2, but that 15 and 2 is not going to get you negative 11 there. So the other factors got to be 5 and 6, and 5 and 6 will get me 11, but it'll only give me negative 11 if it's negative 5, negative 6. So there we go. That's how you would factor that particular polynomial. Okay? Now, let's take look at some other options here, other sorts of factoring questions. What's the next one I got here? I have got y cubed minus 9y. All right, when you take a quick look at that guy right there, very first thing that I want you to do is yank out what's common to both those terms. In fact, that should always be your first step. Okay, now that hasn't happened often in the work that we've done thus far, but that's not to say that that's not a really important step to start with here. So we're going to take out the common y. That'll leave us with this y squared minus 9. Okay, and then just like we've seen before, we ended up with a binomial factor that was a difference of squares. So now I can write that as y minus 3, y plus 3. Okay, now take a look at another form of factoring. So you've seen the difference of squares. In fact, we've seen a few examples of that. Oh, which letter are we at here? That was FG. Let's take a look at this one. X to the 8th minus 1. Oh, I'm sorry. This isn't exactly what I was expecting it to be. This is another difference of squares here. Okay? Now, sometimes people don't see that because when people look at that, they see the 8 there. They assume, well, that can't be a square because the square root of 8 isn't a nice number. But that's not the way that works when 8 is in an exponent. 8 by itself doesn't have a nice clean square root, but x to the 8th does. So this is also a difference of squares. What's the square root of x to the 8th? Well, it's going to be x to the 4th. And when you just think about that, realize that, oh yeah, because when you multiply powers together, you add the exponents. So for me to take the square root of that, all I had to do was take that exponent and divide by 2. The square root of 1 is going to be 1. So x to the 4th minus 1, x to the 4th plus 1. Now what makes this question nice is that there's actually multiple layers to it, because this is also a difference of squares. Now x to the fourth plus 1 doesn't work. It's a sum of squares. But x to the fourth minus 1 works okay. The square root of x to the fourth is x squared. And so I break that apart into x squared minus 1, x squared plus 1. And then I look at this and notice again that very first factor that I've got there is also a difference of squares. Oh boy, so I do that. So this is going to be, now actually before I do that, I'm going to write down these other two terms because I don't want to forget about them. But neither one of those can be factored any further because there is no tool that I have right now at this level that allows me to split that up. There is no sum of squares. Okay. But this difference of squares here, this can be broken down into x minus 1, x plus 1. And that is about as far as that can go. I'm going to show you an example in a little bit here of a way that we could possibly take this a little bit further. But for right now, that's a good place to stop there. Now, we're going to change gears a little bit. I'm going to show you another variation of this. What if the question was x to the sixth plus 8? Okay, well, it's not a difference of squares for sure, mostly because that's not a difference there, that's a sum. And then, like 8 again is not a perfect square. However, this is, in fact, something a little different. This is what we would call the sum of cubes. And actually, I can factor the sum of cubes. In fact, I can factor either the sum or difference of cubes. Let me show you how this works here. So, just for the time being, maybe let's do this. So before I factor that, I want to show you something. If you've got a cubed and b cubed, and let's say you can either add them or subtract them, and I'll show you both. The way this works here, the formula for this would be a plus or minus b. So it depends what it is. So if it was addition here, it'll be addition here. If it's subtraction here, it'll be subtraction here. So there's your first step. So cube root. And then we're going to multiply that by, and here's how this goes here. You take that a, that first term, and you'll square it. Then what we're going to do, this next term here is going to have the alternate sign. So it's going to be negative or then plus. So if this is positive here, it'll be negative here. If it's negative here, it'll be positive here. And then we multiply those two cube roots together, so AB. And then at the end here, we're simply going to add, regardless of what goes on up here, we're going to add b squared. Okay? So now, let's take a look at our question again. X to the sixth plus 8, okay, is now going to equal, well, what's the cube root of x to the sixth? Now remember how to do that. What you're going to do is you're going to take the exponent and divide by 3. We're going to take that to the 1/3. Well, that's going to give me x squared plus, what's the cube root of 8? 2. Then in here, this will be x to the fourth, because you're going to square that first term, minus, opposite sign, multiply these together, 2x squared, and then add the b value here squared. Okay? I hope that makes sense. I hope that makes sense. It's just this little pattern. We're going to see this pattern show up at least a couple more times. I'll show you some things that you can do with it, I should say at least. It'll show up again here in a second. But there's your sum and difference of cubes. Okay, let's take a look at another question here. Let's say that I gave you x squared minus 3 and asked you to factor this. Okay? Now, I'm going to show you a couple questions in a row. One of them is a difference of squares, and one of them is going to be another sum of cubes here. I'll show you in a second how this works. This right here, if I was to ask you to factor it, for the most part, people would say, okay, I can't go any further than that. That's the end. Okay, that's as far as this can go here. And actually, you're absolutely correct. I would not expect my students to, if they were working through a problem and they got to this point right here, I wouldn't expect them to really factor this any further. The reason this is here is so that we can have just a little conversation about how you might take this a little bit further. I've got two terms and subtraction in between them. This does sort of have the form of a difference of squares. What's the square root of x squared? Well, that's x. Now, what's the square root of 3? And this is where most people say, wow, see, that's the problem. You can't go any further than that because this square root of 3 isn't a nice number. Yeah, but I could do this. Yeah, I could. And so that is a possibility. Now, I don't I don't really want people doing this in general. Okay? Because once you kind of open that door, you'll see that, oh, well, if that's the case, then I could very easily do this. Okay? I could split that up, make this x plus root 3 back here. I mean, that's that last term. But I could take that and make that, hey, root x minus root 3, root x plus root 3, and then I could keep going here, you know, root x minus root 3, and like I could keep doing that forever. So I don't want this to be kind of your default approach to this. However, there will be one or two questions that you're going to bump to in this course where you're going to see that you can find some benefit in recognizing when this occurs. There should be a couple of places where all of a sudden, oh, if I expand that, if I factor that, I might be able to cancel and answer the question a little quicker. Now, another version of that, okay, would be something that looks like this, x plus 27. Because I could ask you to factor this one here. Now, on the face of it, it's like you'd look at that and say, well, my gosh, what the heck would I have to factor here? Actually, I can think of this as the sum of cubes. Okay? What's the cube root of x? Well, that's just it. It's the cube root of x. Plus, what's the cube root of 27? Oh, 3. And then remember the way the pattern works. I take the first term there and I square it. So this becomes the cube root of x squared. Change the sign, so minus. Multiply those two together, so 3 multiplied by the cube root of x. And then back here, you're going to add that second number squared. We'll add 9 squared, and then 3 squared. Add 3 squared to get 9. Close that off here. Again, I don't really want you doing that as kind of a default approach to this problem, but recognize that that is a possibility just in case something needs to be simplified a little bit further than what you're getting there. Let's try one more. Okay, so let's say I've got x plus 1 cubed minus 1. I just want to take a look at one quick example of a problem like this and then move on here. What I'm concerned about people doing here is taking a look at this problem and thinking, oh, okay, well I can do this, and they expand this x plus 1 out. And then they cancel the ones and then factor what you're left with. Now, that will work, okay? That might get really awkward though, but it'll work. I want you to recognize though that this has the overall structure of a difference of cubes. And so in fact, what I might do here is I might simply let a equal x plus 1, just to simplify what's going on here so that I'm seeing only one level of mathematics at a time. So if I let that happen, this question becomes a cubed minus 1. Okay? Now that I can factor as my difference of cubes. So the cube root of a cubed is a, and the cube root of 1 is 1. So this will be a minus 1. Then you take the first term squared, change the sign, multiply those two terms together, so it'll be 1 times a, and then I will add the last term squared, 1 squared, 1. Okay, so this is the first level of factoring, the first level or stage of mathematics that I bump into here. Now, I got to bear in mind though that that's not what this was. It was this. It was x plus 1 cubed minus 1. And so now I got to make that substitution back in for a. So this is going to become x plus 1 minus 1. So I'll go back and show you what I just did there. I replaced the a with x minus 1, minus 1. Then I will get x plus 1 squared, a squared, plus x plus 1 plus 1. So a squared plus a plus 1. All right, now this is all in terms of just the x. So I'm back to the same variable I started with. Now what I'm just going to do is what the work that's inside each of these larger sets of parentheses here. I'm going to drop the inside set here. X plus 1 minus 1 is just going to give me x. Then here, there's really no more factoring I can do here. So what I'm going to do is I'm going to expand out that x plus 1 squared here. And I know that seems a little weird to think about expanding that, but because I want to simplify this as far as I can. So I'm going to get x squared plus 2x plus 1. We'll drop the parentheses here, plus x plus 1, and then plus that 1 at the end. So I'll get x multiplied by x squared plus 3x, 1, 2, 3, plus 3. Now here we go. So x times x squared plus 3x plus 3. Now I would love it if I could factor this a little bit further. But when I look at that right off the top of my head, I'm not sure that I can. Now it's a quadratic, and I've got lots of experience factoring quadratics. But every once in a while I do get myself in a position where I'm not entirely sure. Now one thing that I can do here, think back to your math chapter on quadratics. I can check the discriminant. That discriminant was such a useful little tool here. That's going to be 3 squared minus 4 times 1 times 3. Okay, based on this trinomial right here. That is going to get me 3 squared is 9 minus 12, okay, negative 3. Okay, well my discriminant is negative. That means that if I was going to try to solve this equation right here, I would get a solution that has no real roots. Now bear in mind, roots are related to x-intercepts, which are related to factors. So if there are no real roots here, then there's no way I can factor that. That is the end of this particular problem here. That's it. That's as far as it's going to go. Okay, so that was a little bit of an overview of a bunch of different methods of factoring that you would have seen in the past. Maybe the introduction to the sum and difference of cubes. Now we're going to move on and take a look at what on the face of it is a much simpler form of factoring, but in this course can actually prove to be quite challenging.
Now we're going to look at common factoring.
All right, now we're going to take a look at common factoring. Okay, and what's odd about this is we're going to kind of end with this, and yet this is probably where you started when you started learning factoring here. The reason why we're coming back to this is because in a lot of the work that you are going to do in this particular course here, common factoring is actually the most useful tool in terms of simplifying an expression here. Now, it can also be quite difficult, oddly enough. Now, before we even get into this, common factoring is simply something like this. If you've got ax plus a, you're simply looking at both of those right here and realizing that, hey, a is a factor here, a is a factor here. So I can see that a has been distributed through. But that distribution property applies when you're multiplying across a binomial, across a sum. So I can actually write that in a simpler way by simply writing that a once multiplied by that binomial. So the distributive property now tells me that that a would go to both of those. Okay, and that's all we're taking advantage of. Now, if this ended up being a squared x plus a, okay, now I can see that there's two factors of a here and a single factor of a here. The single factor is the limiting one, okay? It's not like a squared has been distributed to two terms, because that simply wouldn't work. It's just one single a that's been distributed, and it just got distributed to an ax plus a 1. And that's where my a squared is coming from when I distribute that to this term, and then to the next term, a times 1 is just a. So that's all we're doing. And we're typically going to yank out, okay, we're going to factor out powers with the, whoops, wow, did that in one word there, with the smallest, and I can't emphasize that enough, smallest exponent. Okay, smallest exponent. Now let's take a quick look here. So to begin with, let's say for example that I had x to the 5 halves minus x to the 1 half. Now we kind of jump in with both feet here because I'm immediately taking you to a question where there are fractions in the exponent. Yeah, we're gonna just rip off that band-aid and just get right into it, okay? You got to be prepared for this. This is going to be kind of just the fact of your reality at this point here. Now, I see that there's a common factor that's a power of x here. Now, between 5 halves and 1 half, which exponent is smaller? Well, the answer is this one, x to the 1 half. So that's what I'm going to factor out, x to the 1 half. Now, factoring is essentially division. So to do this, to take that x to the 1/2 out, I'm going to divide both of these terms by that x to the 1/2. I mean, that's what I did up here. How did I get ax plus 1? I divided ax squared by a. I divided a by a. That's how we do it. So if I divide x to the 5/2 by x to the 1/2, remember that when I divide powers, I subtract exponents. So 5/2 minus 1/2 is going to be x to the 4/2. Now please, I beg of you, don't write it like that. Just take 2 seconds and think about that. X to the 4/2 is x to the 2. And then when I divide that out of x to the 1/2, I will get 1. Good. Now I'm not quite done yet though, because x squared minus 1 is a difference of squares. So this will be x to the 1/2, and then I can factor that down one bit further here. X minus 1, x plus 1. Okay? Let's take a look at another one here. Let's say I've got 4x to the negative 1 minus 10x to the negative 2 plus 6x to the negative 3. So yeah, I know. Now all of a sudden we're throwing negatives up there. Now, and I know this can be difficult for people. I don't want to downplay that. I recognize that when you probably started learning to work with exponents, that was a struggle for a lot of people. I get it. That's why we're kind of taking this little section here and doing it all on its own here. So I see, first of all, I look at the coefficients, 4, 10, 6. There is a common factor of 2 to all three of those. So I will divide that out. Now there's also a common factor of x. It's a power of x. The reason for this question here is so that we can have a quick discussion about what's the smallest number that I'm going to yank out here. Please don't say negative 1. That's not true. Negative 3 is in fact smaller than negative 1. Okay, and if that's striking you as sounding a little bit odd, just quickly draw out a number line and identify where negative 1 and negative 3 are on that number line. Negative 3 is smaller than negative 1. When I yank that out here, 4 divided by 2 is 2. X to the negative 1 divided by x to the negative 3. Now here's where this is typically going to be confusing for people. But I'm dividing it out here, so I'm dividing the powers. But when you do that, you subtract the exponents. So this becomes negative 1 minus negative 3. It's this minus negative that causes all the problems here. That's like negative 1 plus 3. And that actually gets me the number 2 there. Okay? Then I go to the next term. Negative 10 divided by 2 is going to be negative 5. Then, bear in mind that I'm dividing this x to the negative 2 by x to the negative 3. Well, okay, negative 2 minus negative 3 is going to be negative 2 plus 3, okay, which is going to get you 1. Whoa, excuse me. I'm embarrassed. Okay, let's keep going. But x to the 1. And I don't need to write that 1 if it's to the 1. That's fine. Finally, moving on here, positive 6. Divide by 2 is going to be positive 3. And then when I divide x to the negative 3 by x to the negative 3, I'm just going to get a 1 there. So there we go. So all the rest of the stuff that I threw down there that was just helpful. So here we go. Now, let's just see if this is the end here. Can I factor that further? Let's just try this. 2x, x. All right, now, if I'm going to get a negative 5 there and a positive, first of all, I know that both of these have to be negative if the product is positive and the sum is negative. And if I make this negative 1 and negative 3, it'll become negative 2, negative, yeah, there's my negative 5. So exactly, I had to go a little bit further to factor that trinomial. Good question, really good question. Oh, sorry, that was B. C. Let's take a look at a new one here. Let's try this one. X plus 5 plus 6x to the negative 1. I really like this question. I really like this question because of the conversation that it kind of forces us to have here. Because a lot of times people will look at this and say, I'm off the hook here because there is nothing common to all three terms. Okay? It's like, accept that. Except that the rule is we're going to factor out the power with the smallest exponent. Okay? Now, watch this. I can rewrite this as x plus 5 times. Now, here's the trick. I can write this as 5 times x to what exponent? Well, there's no x here. But if I write this as x to the 0, well, what's x to the 0 is 1 times 5 is 5. So this is actually the same as this. Plus 6x to the negative 1. Oh, so now that x to the negative 1 actually still, regardless of the fact that you're not seeing an x in every one of those terms, that x to the negative 1 could still be considered a common factor. So I'm still going to have to take out that x to the negative 1. Now when I do that, when I divide x to the 1 by x to the negative 1, just think about that. When I come over here and I divide this by x to the negative 1, 1 minus negative 1 becomes x squared. Now, here's where the fun begins. I've got 5 divided by x to the negative 1. Well, okay, again, that's like x to the 0 divided by x to the negative 1. So 0 minus negative 1 is x to the 1. And now over here, when I divided out the x to the negative 1, I divided it out, so it's gone. And so I'm left with this trinomial right here. So x to the negative 1, and then this is a trinomial that can be factored down quite nicely as 2 and 3. And I'm hoping at this point you've probably even done that one like dozens and dozens of times. So hopefully that doesn't strike you as weird. But it's that even though you're not seeing that x is common, as soon as you've got an exponent that's less than 0, you have to factor that out. Okay? And think about that. That's that little rational there that has to be factored out. Okay, and actually I'll show you another question here in a bit where, yeah, you'll see that idea come up again in a different context. Let's do another one here. Let's say that we've got, well actually, I tell you what, now that we've talked about it, let's do it again right now. I'll choose a different question here. Here's 1/2 x to the 1/2 minus 2x to the negative 3/2. Oh, there's so much going on in this problem. I love it. Okay, now, first of all, look at the coefficients here, 1/2 and 2. But think about it like this. 1/2 is the same as, this is just like writing 2 to the negative 1. Whereas this here is just 2 to the 1. They're both powers of 2, but this one's got the smaller exponent. So I'm going to take out the fraction because it represents a power with a negative exponent, just like we did here. That x to the negative 1, that's what came out. This right here, 2 to the negative 1, and again, if you're not comfortable with that, that's going to be very hard to see. But that's 2 to the negative 1, that's what's going to come out. So I'm going to factor out 1/2. Between the two factors of x here, x to the 1/2, x to the negative 3/2, negative 3/2 is the smaller exponent, so I am going to factor out a 1/2 and then an x to the negative 3/2. Now, from this first term, 1/2 divided by 1/2 is 1. So the coefficient I'm left over with will be 1. Now, x to the 1/2 divided by x to the negative 3/2. Okay, well, 1/2 minus negative 3/2 is going to be 1 plus 3/2. That's going to be 4/2 or 2. Then over here, I'm going to divide negative 2 by 1/2 first of all. Now bear in mind what I said. I didn't say 2 divided in half, because that would be 1. I said 2 divided by half. And so to do that, you have to multiply by the reciprocal, and that's going to get me negative 2 multiplied by 2, or 4. And then the x to the negative 3/2 cancels, and so there you go. Really common mistake that people make here is misunderstanding what I'm saying here. Not negative 2 divided in half, but by half. Now, you should see that difference of squares that has popped up here. So this is 1/2 x to the negative 3/2. This will become x minus 2, x plus 2 when we deal with that difference of squares. Okay? Let's take a look at another one. Okay. Let's take a look here at x squared plus 1 to the 1/2 plus 3x squared plus 1 to the negative 1/2. Okay, now the only thing that has changed here, is that now one of my factors is a binomial. Okay? And actually for the rest of the questions that we looked at, you're going to see these binomials in there, whether they're part of the common factors or not here. So just watch, between these two terms here, there is a common factor of x squared plus 1. But I got to grab the smallest exponent. In that case, it's going to be the negative 1/2. So when I divide out this by x squared plus 1 to the negative 1/2, it's going to be positive 1/2 minus negative 1/2 when I do the division. That leaves me with x squared plus 1 all to the 1. But I wouldn't write it like that, because if it's to the 1, then I don't really need those parentheses there. Plus, well, when I divided this secondary term here by x squared plus 1 to the negative 1/2, those are just going to cancel. And so I'm only left with the coefficient, the 3. And so now altogether, this will be x squared plus 1 to the negative 1/2 multiplied by x squared plus 4. And because that is a sum of squares, that's the end of that one. I'm not going to take that any further. Okay, let's take a look at another one here. Let's say x to the 3/2 plus 3/2 x to the 1/2 x minus 3. Now, like I said earlier here, this one has that binomial factor in it. However, it's not a common factor. Now, when I take a look at this, a couple of things I notice here. First of all, I've got a factor of x common to both, so I'm going to take out the x. The smallest exponent between 3/2 and 1/2 is 1/2. Okay. But in addition to that, notice that I've got the rational here, and I've got a 2 in the denominator. I've got a 2 in the denominator. It means if I was to write that 1/2 there, now I understand there's a 3 there, but I can separate that out, make that 3 times 1/2. This is like 2 to the negative 1. Over here, with no coefficient out front here, or a 1 is a coefficient, this is like 2 to the 0. I actually have to take out that denominator. I have to take out that fraction. Now, in my first term, 1 divided by 1/2 is going to give me 2. 1 divided by half. Now, again, it's not 1 divided in half, it's 1 divided by half. Okay? Then, if I divide the power of x here, x to the 3/2 divided by x to the 1/2, remember I subtract the exponents, so 3/2 minus 1/2 is just 2/2 or 1. So this becomes 2x, x to the 1. I divided out the 1/2, so I was simply left with the 3 there. X to the 1/2, I divided that out with, and then I'm left with x minus 3 as that final factor there. Now, to put this in a form that I would rather see, what I'll do here is I will multiply the 3 through, distribute it to the binomial here. Then now I'm going to get 2x plus 3x will be 5x. And then 3 times negative 3, there's my negative 9. Okay, and there we go. So 1/2 x to the 1/2 multiplied by 5x minus 9. Now we're just going to do a few more. Just a few more. Whoops, not m. Sorry. I glanced in the wrong space. I've got kind of a big one here, but it's not that bad to work with. 4 plus 5x squared multiplied by 8 minus x to the power of 5 plus 8 minus x to the power of 6 multiplied by 4 plus 5x. Okay? Now, a couple of things can be said about this as we go through this, but we'll get there in a second here. Now, first of all, I see that there is a common factor of 4 plus 5x and a common factor of 8 minus x. Okay, that's dealt with. Now look at the 4 plus 5x. What's the smallest exponent on that binomial factor? 1. So take that up to the 1. 8 minus x, what's the smallest exponent? 5. And so when I divide this out from those terms, the 8 minus x to the 5 is going to cancel, and I'm going to be left with a 4 plus 5x here to the 1. Well, which means I don't need the exponents there. Over here, when I divide that out, I will divide out the 4 plus 5x, so it's gone, and then 8 minus x to the 6 divided by 8 minus x to the 5 is simply going to leave me with 8 minus x left over. So now, all that's left for me to do here is to simplify this. So 4 plus 5x multiplied by 8 minus x to the 5th. This is going to be 4x plus 12. Okay, now, there's a few things I want to do here. I want to clean this up. This is almost okay. It's not completely factored yet because there is a common factor of 4 that is now popped up here, and I need to deal with that. But there's a couple other things that I need to deal with here. First of all, I am going to deal with that common factor 4. When I pull it out, I'm going to pull it right to the front. Now I'm going to do one other thing here. I don't like the way that looks. 4 plus 5x. That doesn't feel right to me. I'm going to change the order and make that 5x plus 4 to the 1. Now, order does not matter with addition, but I've got the highest degree term first. I like that. I am going to do the exact same thing here. I'm going to make this negative x plus 8 to the 5th. Okay? And then back here, I was left with x plus 3. Now I'm going to do one more thing here. Right here. Right here. I don't like the fact that there's a negative in front of that x. So what I'm going to do is, within this set of parentheses that's being taken to the 5th, just within it, I'm going to factor that negative out of that binomial. And what that's going to do is that's going to make this positive x minus 8 inside there, and then all to the 5th. So there's a negative 1 multiplied by x minus 8, and that's all to the 5th. But negative 1 to the 5th is still negative. That negative I'm going to yank right out to the front because order does not matter with multiplication. So I can do that. I can pull that right up to the front. X minus 8 to the 5th, x plus 3. Now that's a much nicer looking expression. I like that. Everything's in the correct order inside there. The negative has been yanked to the front. Perfect. Love it. Couple more. Let's try this one. 1 minus x squared to the 3 halves minus 3x squared multiplied by the square root of 1 minus x squared. Okay, very common mistake that people make is they jump to this one and they take the square root of 1 and get 1, square root of x squared and get x. And oh no, you can't do that. Okay, order of operations says that before you could apply the square root, you would have to do what's inside there first, which is 1 minus x squared. So unless you know what that is right now, you cannot take the square root of those pieces. You have to take the square root of the whole thing. You'd be far better off instead writing that like this. 1 minus x squared to the 3 halves minus 3x squared multiplied by 1 minus x squared to the 1 half. Rewriting that radical as an exponential expression. Now I see that I've got 1 minus x squared common to both terms. So 1 minus x squared, and the smallest exponent is going to be to the 1 half. Now, when I divided that out of that first term, remember this, that when you divide powers, you subtract exponents. So 3 halves minus 1 half is 2 halves, which is just 1. So I'm just going to write 1 minus x squared. Okay? Now, over here, I divided out the 1 minus x squared, so I'm left with this negative 3x squared. That was my coefficient. So here we're going to get 1 minus x squared to the 1 half, and then inside here 1 minus 4x squared. Good. Now, I'm going to do one more thing here. Now, ultimately, I would love to change the order on this to make this negative x squared plus 1, and then take out the negative. But the problem is that negative is under a square root. That 1 half represents a square root. That is a problem. Okay, because I'm not at this point able to take the square root of a negative. That's going to give me a non-real answer. I can't do anything with that. So honestly, that is about the prettiest that I'm going to be able to get that. So I'm going to end up leaving this in that incorrect order. But that actually gives me a little bit of freedom here. I mean, this is already going to be in the wrong order, so I'm not all that upset when I take this guy right here. I'm just going to treat this as a difference of squares, make this 1 minus 2x, 1 plus 2x. So in this case, because I'm kind of stuck with it like this, it doesn't beat me up that I'm gonna leave these guys with that 1 minus 2x, 1 plus 2x right there. That's okay. Okay? Because this looks better than it might otherwise if it's inconsistent. It doesn't matter. But anyway, there you go. One more. Let's take a look at one more here. 6x, 1 minus 2x to the 4/3 minus 8x squared cube root of 1 minus 2x. So once again, you can't distribute that cube root to both of those terms. The best we can do is take and write that as 1 minus 2x to the 1/3. Now, I've got a little bit that's common here. Between the 6 and the 8 here, the coefficients, there's a common factor of 2. I've got an x and an x squared. That's a common factor of x to the 1. And then 1 minus 2x, well, between 4/3 and 1/3, the smallest is going to be 1/3. Now, multiplied by what? Okay, when I divide this out, what's left over? So 6x divided by 2x is just going to be 3. 1 minus 2x to the 4/3 divided by 1 minus 2x to the 1/3. Well, just subtract the exponents. 4/3 minus 1/3, well, it's 3/3, which is just to the 1. So this will be 1 minus 2x to the 1. And then we're going to subtract from that. I'm subtracting, so just say 8x squared divided by the 2x is going to give me 4x. And then I'm going to divide out that 1 minus 2x to the 1/3, so that's going to be gone there. So here, we're going to be left with 2x. Now, watch this. I don't like the order that that's written in, so I'm going to change the order, and I'm going to take the negative out. And now, this time I can do it because it's a cube root. It's to the 1/3. So I can actually take that negative right out and make this 2x minus 1 to the 1/3, because the cube root isn't going to have a problem with a negative. I love that. Now inside here, I'm going to get 3 times negative 2x. It'll be negative 6x minus 4, so negative 10x plus 3. Okay? Now I'm just distributing that out and simplifying it. Oh, I'm left with another negative in here, so I'm going to take the negative out of here, which will cancel with that negative that's up front. So this will be 2x minus 1 to the 1/3, and then this is going to become 10x minus 3, and I took that negative out of here because it looks better if in the binomials and whatnot you don't have the negative as a leading coefficient. Awesome. That looks wonderful. Okay, so we had a bit of practice there with different forms of factoring and a bit of practice with just common factoring and looking at what happens when you've got negative exponents, fractional exponents, and so on. So I hope that gives you something to work with. In the next lesson, we're gonna apply some of the things that we've looked at with factoring to take that one step further, along with some other ideas that are important.